All right, we're back to the 2025 AP Calculus AB FRQs, number 4. All right. As I have told you guys, you're always going to be presented with one of three different types of problems. Either it's going to be the function, the graph itself, or you're going to get a data table. In this case, we've got a graph along with a little bit of a function to consider that explains this graph. The important thing to gather with this one is really just the fact that here you actually are given this graph of f, and that is actually the derivative of g of x. So you can think of you have your function, the derivative, and then the second derivative. All right. So here our function is f of t, and then the integral of that is g of x, right? When you consider that, okay? So finding g prime of 8, you can understand here a g prime of the function is now actually f of x here. And they're looking for g prime of 8, which is f of 8. So we're just going to go look at the graph of f. At number 8, we have equals 1. That's all you got to do. You got to make sure you show this though, that the derivative of g of x is that f of x, because that's what the definition of this x goes into your function. And then plugging in your 8 gets you 1. As you can see, g of x is equal to f of x. We got that first point. Then plugging in our function 8 gets us the 1. So we got both points right there. Very, very quick. Back to the problem. Number 2, find all values of x on the open interval from -6 to 12, at which the graph of g has a point of inflection. Give a reason for your answer. So what this brings to mind for me is, remember, you have the function, you have the first derivative, and then you have your second derivative, okay? And so we have g of x up here, f of t or f of x here, and then you have the derivative. Okay, point of inflection is in the second derivative. That's when your point of inflection is when it equals 0. Okay, so we're actually looking for the derivative of this equaling 0. Now, conceptually, what that should make you think of is that you are now separating these into their slopes. And a point of inflection is when these slopes go from negative to positive or positive to negative. So what that means is we've got this point right here, this point right here, and this point right here. Okay? So that means x values on the open interval, x is equal to -3, 3, and 6. Okay? But you have to give a reason for your answer. Okay? So here what we can say is that f of x, this equation, right, goes from negative to positive at these 2 points. Actually, we got to call this f prime of x, right? That's it. And then goes positive to negative at 3. All right. Those are your points of inflection here. 1, 2, and 3. Let's go into our answers. We can see the graph of g has point inflection where the double derivative of g is equal to f prime changes, where that changes from decreasing to increasing or vice versa. Graph of g has points of inflection at these 3 points, 1, 2, and 3. Okay? There's a lot of different ways that you can actually score for this one, but realistically, you have to make sure that you show that you understand the concept of your point of inflection. back to the problem. Find g of 12 and g of 0. Label your answers. Okay, so that brings us back to this equation here. G of 12 is going to be the integral of f of t from 6 to 12. Okay, so that's going to be this entire area right here. All right, so here we have a distance of 6 down here and a height of 3. That's a total of 18. Cut that in half for your triangle. So half of 6 times 3, that's 9. Okay, so that's going to be your first answer for g of 12. Now g of 0, we got to keep in mind this is now going backwards. 6 to 0 is going backwards, so this is now a negative value. We have a radius of 3. Okay, so f of t dt. Okay, now we go pi r squared, and we cut that in half, right? R is equal to 3, so we have pi times 9 over 2. That's going to eventually be 9 pi over 2, or you can say 4.5 pi. Keep in mind too, in this situation, do we have uh any sort of units to worry about? No, here you can say units squared for that, but realistically that's, you are finding area under the curve. If this was in miles, if it was in inches, etc., make sure that you have your label for those answers. Okay? Oh, that's where I mentioned it, but I didn't write it out. It's a negative. My bad. Okay. So the two equations, write them all out. Make sure that they are explained, and then you're solving. Write them out, show your explanation, and therefore you have your answer. Find the value of x at which g attains an absolute minimum on the closed interval -6 to 12. Okay. Justify your answer. What is our absolute minimum? Well, keep in mind too, you have in this situation, this would be a positive value. Here you have your negative value, and then you have adding a negative value. So really, let's use color codes for this actually. This is positive, right? Because you start at 6 going this way. That's a positive value. This is a negative value. And technically, because we're going backwards, this is a positive value. Okay? So we can say in terms of the visual here, that's not necessarily going to be the best way to show and justify your answer. Now, let me use a color you can see. So we're going to go and say this function, g of x, is equal to the integral of 6 to x f of t dt. Now, we already did find g of 12, right, which was our 9. We also have g of 0, which is our -9 over 2 pi. Okay? If we go all the way down to 6, or -6, sorry, then we actually would go -9 pi over 2 plus 9 pi over 2. So that's actually equal to 0. So therefore, our most negative is going to be this. All right? You could also, in this situation, show what is an absolute minimum. Absolute minimum, we can talk about how, right, we have our function, we have our derivative, and we have our second derivative, okay? Where our derivative is equal to 0, and our second derivative, if we want an absolute minimum, needs to be a positive value. That makes sense? Okay. So G attains an absolute minimum. That means G of X is up here. We want the first equation to equal 0, right? So this is our graph of F, our first derivative. G prime of X is equal to F of x. So that means our zeros are the points we're going to test. Okay. And then we would go and we would plug those in. So g of -6, g of 0, and g of 6, right? This one is going to be a 0, and we have the answers for the other two already. Now, with that being said, our absolute minimum you can see right away is this one. Checking our answers in here. Our derivative equaling 0, right? F of x equaling 0. That's where we consider that. Plugging in our values, which we do have. We technically also have 12 as well, all right? And showing our interval absolute minimum at 0. All right, that one was actually pretty quick, okay? Keep in mind, if you can save, if you've got 15 minutes for each of these problems, every minute under 15 means you get that much time, more time for your other problems. That's number 4. We still got 2 more to go through. But of course, I'm breaking these down so you can digest them in some smaller pieces. If you do have questions, please don't hesitate to leave a comment, leave a message, or you can always contact us over at exclusivetutoringsd@gmail.com. Be happy to help you guys out with getting a 5 on this AP Calculus AB test coming up in May. I'll see you guys in the next one.